Hi, and thank you for joining us in our AWS Storage Virtual Workshop. Today we'll be covering centrally managing and automating backup policies with AWS Backup. My name is Avi Drapkin, and I'm a Senior Storage Solutions Architect. And with me is Fatima Kamaluddin, who is also a Senior Storage Solutions Architect. So as part of this workshop, our learning objectives are to get a general overview of AWS Backup and its capabilities. By the end of the session, you should be able to understand how to utilize AWS Backup to protect your AWS resources, configure backup plans, as well as restore data protected by AWS Backup. The workshop is split into 7 different modules. In Module 1, we'll deploy our workshop resources into your chosen region. In Module 2, we'll create a backup plan for critical volumes. Module 3, we'll secure recovery points in our vaults. In Module 4, we'll create an on-demand backup of existing resources in our region. And in Module 5, we will recover deleted data. And in Module 6, we'll perform a backup and recovery using AWS Backup's latest feature, which is VSS snapshot integration. And finally, we'll clean up in Module 7. There's a link provided at the bottom which will take you to the instruction page for this workshop. Part of this workshop deploys a CloudFormation template to automatically deploy our resources that we'll be utilizing. This usually takes 15 to 20 minutes to deploy. We're going to switch over and deploy our CloudFormation template to give it time to deploy, and then come back to give the overview of AWS Backup. I'll go ahead and turn off the video when we do the demonstration. For ease of use, I have a browser already open to the page. On the left, I have the instructions for the workshop, and on the right, I've opened up a browser and I've logged into my AWS Management Console. You'll want to ensure that the user that's logged into your AWS Management Console has the appropriate privileges. As part of the CloudFormation template, we will be deploying AWS IAM roles, VPC, Amazon EC2 instances, EBS volumes, EFS file systems, AWS Backup resources, and of course, CloudFormation. So we'll need to make sure that your user has access to that. As part of the prerequisites, it's really advised if you use Firefox or Chrome as part of this workshop. You'll also need an RDP client, as well as a key pair for your EC2 instances. If you're unfamiliar with the EC2 key pair, there's a link provided on how to get started with that. Let's scroll down to the bottom here of page 2, where you can deploy this workshop in one of 4 regions: US West 1, US West 2, US East 1, or US East 2. For the purposes of this demonstration, I will deploy in US West 1. Right-click and hit Open Link in New Tab. This should take you to the CloudFormation stack here. Click Next. Here in the Access Key pair, we'll select the key that you have registered within your EC2 console. For remote access IP address, it's recommended that you use your IP. You can find your IP via ipmonkey.com or a simple Google search of what's my IP. When you do that, you should enter in your IP address with a /32. Also enter in a valid email address. Leave the next 2 fields defaulted. We'll click Next, Next again, and scroll all the way down and Acknowledge. And then click Create Stack. You should see a Create in progress. Let's flip back to our presentation where we will learn a little bit more about AWS Backup while this deploys.
Thank you, Avi. Hi, I'm Fatima, and I'm going to go over the introduction of AWS Backup and how to protect your AWS resources using AWS Backup. I will also go over some of the recent feature launches that offers the flexibility to monitor backups across hundreds of AWS accounts in an organization, and the introduction of EC2 application-consistent backups. So let's get started. Some of the challenges that our customer faced with respect to backups were complexity, compliance, and cost. Customers had to run custom scripts to automate and manage the backups, especially when customers were using different services and their backups. Customers also had to mine these distributed logs of different services in order to troubleshoot any issues. On the compliance front, customers had a difficult time reporting for audit and compliance and a lack of automated policy enforcement for data protection. The time and resources allocated to build, maintain all these data protection tools using complex scripts was proving to be expensive time and again. To solve all of the above, we introduced AWS Backup. AWS Backup is a fully managed backup service that makes it easy to centrally manage and automate the backup of data across AWS services. Using AWS Backup, you can centrally configure backup policies and monitor backup activity for AWS resources such as Amazon EBS volumes, Amazon EC2 instances, Amazon DynamoDB, tables, Amazon RDS databases, Amazon EFS file systems, and AWS Storage Gateway volumes. AWS Backup automates and consolidates backup tasks which were previously performed service by service, removing the need to create custom scripts and manual processes. How AWS Backup works. With just a few clicks in the AWS Backup console, you can create backup policies that automate backup schedules and retention management. AWS Backup provides a fully managed, policy-based backup solution, simplifying your backup management, enabling you to meet your business and regulatory backup compliance requirements. You can create a backup plan within AWS Backup Console and define the parameters such as schedule, backup window, lifecycle, copy to different regions and vaults, and have the backups run on an automated schedule. You can set user access permission to managed resources and control it via identity and access management. You can set up notifications and logging through the integration with AWS Simple Notification Services and AWS CloudTrail. How does AWS Backup integrate with other services? AWS Backup integrates with other services in two modes, the control plane and the data plane. AWS services such as Amazon EBS volumes, Amazon EC2 instances, Amazon RDS databases, Amazon DynamoDB tables, and AWS Storage Gateway volumes integrates in the control plane, which means AWS Backup works as an orchestration layer over these services. It uses the existing APIs and runs the backup of these services, thereby providing a replacement for custom scripts and or any processes to manage these backups. On the data plane, EFS operates in the data plane that allows advanced features and the ability to lifecycle to lower cost storage, allow encryption from the source, and it will also allow individual file system restores. What is a backup policy? It's nothing but a set of rules that are created using the steps listed here. So step number 1 would be to define a backup plan that specifies the frequency and timing of backups and have an associated IAM role that has access to these resources. Step 2 would be to define the lifecycle management of the backups to ensure that the backups are expired after a certain number of days, purging any expired backups and minimizing storage costs. The resources are assigned to the backup plan using tags or resource IDs. Tags are a more scalable way if it involves backing up a large number of resources automatically. And finally, AWS Backup also provides a centralized monitoring dashboard view to manage and monitor these backups. Plan-based management for AWS Backup. In AWS Backup, a backup plan is a policy expression that defines when and how to back up your AWS resources, such as Amazon DynamoDB tables or Amazon Elastic File System. When you assign a resource to a backup plan, the resource is backed up automatically. The backups for that resource are managed according to the backup plan. You can assign resources using tags or resource IDs. For example, you can define a backup plan that meets your business requirements for mission-critical data and create a resource assignment with a tag key backup and a tag value mission-critical. then any of the resources with that tag are automatically backed up to the mission critical backup plan. As you can see here, you can assign different backup plans for different applications based on the retention, frequency, or lifecycle management of AWS resources. So this is a snapshot of a backup plan creation process. In order to create a backup plan, you browse into the AWS Backup console, select the backup plan, and you create a backup plan. You have three options to start. You can start from an existing plan, you can build a new plan, or you can define a plan using JSON. Backup rules. Here is where we define the backup rule for the backup plans. We need to provide in a rule name and then set a frequency where you can select the backup plan to run once every 12 hours or daily, weekly, monthly, and also put in a custom cron expression where you can select something as close as an hour. Under the backup window, you can use backup window defaults, which defaults to 5 a.m. UTC start time, or have a customized backup window that would suit your own needs. Under a lifecycle, you can transition to cold storage for EFS backups, and you can let the backups expire after X number of days based on business requirements. Vault. Vault is basically a logical container where you can catalog your backups. Every region has a default vault, but you also have the option to create your own backup vault. The AWS KMS, Key Management Service Encryption Master Key, is used to protect your backups in this backup vault. By default, AWS Backup creates a master key with the alias AWS/backup for you, and you can choose that key or choose any other key in your account. Under regions, AWS Backup now supports copy of these backups to a different region, and you can select the destination region through the pull-down box here and choose the backup vault in the destination region. You can also define the transition lifecycle management by transitioning to cold storage for EFS and have the backups expired after a certain number of days based on business requirements. The tags associated with the recovery points will help you organize and track your recovery points. Once all these rules are defined, you can click on Create Backup Plan and have a backup plan run the backups automatically. My friend Avi is going to be showing this in the workshop that follows this presentation. Feature matrix of AWS services. This is a feature matrix where you can see how different features and services are supported. As you can see here, automated backup schedules, automated retention management, centralized backup and monitoring and logging, KMS, integrated backup encryption, and cross-account management are supported across all the services listed here. Lifecycle to cold storage and item-level restore is available only on EFS since it operates in the data plane. With respect to cross-region backups, this is available on all the services with the exception of DynamoDB. AWS Backup with cross-account management. So what we have observed from our customers is that there are different departments or different business units, and they all have different accounts within AWS Backup. Each of these accounts need to be configured and administered separately. For example, corporate IT department has to manually ensure compliance with the backup policies. And by having to go to each account owner and have a discussion about what the backup settings need to be, what you need to actually protect and backup, the frequency, retention, and all this often leads to inconsistencies and errors. Monitoring and reporting across all these accounts becomes difficult because IT compliance administrator usually doesn't have a single place to view these different accounts. Hence, AWS Organizations and AWS Backup build this feature together. AWS Backup now supports cross-account management, enabling customers to manage and monitor backups across their AWS accounts within an organization. Cross-account management also provides customers with a central view of all their accounts in their organizations, enabling customers to easily identify protected resources or accounts that have fallen out of compliance. With cross-account management, you can use a backup policy to automatically apply backup plan across all your accounts. You can also create a backup policy that uses tag-based resource selection and apply it to all the accounts in an organization or an individual account or an organizational unit to protect their local resources. For example, let's say you define a backup policy, policy A, that takes daily backups of specific resources and keeps them for 7 days. You choose to apply backup policy A to the whole organization. Then you create an organizational unit named Finance and you decide to keep its backups for 30 days. In this case, you define a backup policy B, which overrides a life cycle value and attach to the finance OU. This means all the accounts under the finance OU gets a new effective backup plan that takes daily backups of all the specified resources and keeps them for 30 days. In this example, backup policy A and backup policy B were merged into one effective backup policy, and that defines the protection strategy for all the accounts under the OU named finance. All the other accounts in the organization remain protected by backup policy A. In the backup console, you can select cross-account management where you'll be able to see the backup jobs across different accounts. And you'll also be able to apply advanced filters and filter them by account ID or job status. One of the recent feature releases is the launch of EC2 application-consistent backups using AWS Backup. AWS Backup Service will use a modified version of an existing functionality called VSS Application-Consistent Snapshots to achieve application consistency. This feature uses AWS Systems Manager (SSM) on EC2 and Microsoft VSS, which is Volume Shadow Copy Service. VSS is a Windows component that helps application to back up consistent state, and it also provides a mechanism for creating consistent point-in-time copy of the data known as shadow copies. AWS Backup would snapshot the attached EBS volumes and the AMI, which is the Amazon machine image, with the associated parameters for application-consistent backups. How are shadow copies created? AWS Backup will call the SSM send command, passing the newly created SSM document name along with the required parameters. SSM will pass this call to the SSM agent on the host, which in turn will trigger application-consistent EBS snapshots, followed by an EC2 image creation. The requester, which is the backup application, requests the VSS to gather all the writers, collect the metadata, and gather them for shadow copies. The VSS agent on your instance coordinates all the ongoing I/O operations for running applications. The system flushes all I/O buffers and temporarily pauses all I/O operations. The pause lasts for at most 10 seconds. During the pause, the system creates snapshots of all volumes attached to the instance. The pause is lifted and I/O resumes operation. The system adds all newly created snapshots to the list of EBS snapshots. The system tags all VSS-enabled EBS snapshots successfully created by this process with an app consistent is true tag. Once the work is completed, SSM will update the command status and AWS Backup will attach this newly created EC2 image to the customer's backup. In case of misconfigured instance or errors on the SSM or SSM agent side, AWS Backup will default to the EC2 backup creation flow, and with this, it will be indicated stating Windows VSS backup job error and trying for regular backup. You'll be able to see this in the AWS Backup console. So in order to set up VSS enabled backups, there are some prerequisites we need to set up and have it enabled. IAM roles for the EC2 instances with create tag, describe instances, create snapshot, and Amazon EC2 role for SSM policies. They need to be created and they need to be attached to the EC2 instance. The EC2 instance needs to appear under the managed instances in AWS Systems Manager. And in order to do that, you need to ensure that the AWS Systems Manager agent is installed and the services are running on the EC2 instance. Once the Systems Manager is configured, you need to ensure that we can install the AWS Core Component package by creating an association using the State Manager and install the VSS agent on the EC2 instance. Once we have all this configured, we should be able to run VSS-enabled backups using AWS Backup. I'm now going to hand it over back to Avi, who is going to walk through this workshop that we have put together. Thank you for listening.
Let's go back to the web browser and see if our CloudFormation template deployed. Oh, looks like it has completed. You may need to click this refresh button if it still says create complete. Now that our CloudFormation template deployed, we can go ahead and close this window. We are still logged in on the right side here. So let's scroll back to the very top and we'll talk about what this backup workshop is all about. The CloudFormation template we used deployed a web server backed by both EBS and EFS storage services and configured AWS Backup to provide protection for the web server. It also deployed a Windows Server 2019 instance running SQL Server 2019. We'll use that to demonstrate AWS Backup's latest feature, which integrates AWS Backup with the Windows VSS feature to take application-consistent backups. We'll also get some hands-on with configuring backup plans, taking a look at backup vaults, as well as looking at some of the policy options. And we'll step through the process of both creating on-demand backups, as well as recovering data. As mentioned before, you should be running this workshop via Firefox or Chrome, have an RDP client already installed, as well as having a key pair registered within your EC2 console. Let's step into Module 1. We've already deployed the CloudFormation template, but let's go over what the CloudFormation template deployed in detail. The CloudFormation template deployed an EC2 instance that is running our web server. Attached to that EC2 instance are some EBS volumes, both the root volume and a data volume that is hosting our web server data. We've also deployed a SQL Server instance that also has a root volume as well as a data volume where the database is located. We also have an EC2 instance that has a root volume attached to it, and that EC2 instance is going to be our admin server, which we'll be performing some backup functionality on. And deployed for later use, we have a SQL Server Restore instance that just has a single root volume where the operating system is installed. Along with that, we have our EFS file system that also is preloaded with our data for our web server. And with AWS Backup, we have created both a silver backup vault as well as a gold backup vault, which we will use later. We are also using SNS, or Simple Notification Service, to get emails on backup status. So we've already deployed this, so I will skip ahead. To the confirmation step. On the right-hand pane here, let's go ahead and confirm our resources were deployed. So click on Services, and then type in SNS to get to the Simple Notification Service. We're going to click on Topics, and we're going to verify that our backup SNS topic completed properly. You should see a pending confirmation. Let's check our email to see if we received a notification to register. Sure enough, here's our backup topic. Let's click Confirm Subscription. This will ensure that backups occurring within this workshop will send us the notification whether or not they succeed or fail. Now that we've confirmed, we can refresh this page and it should say confirmed. Great. Let's confirm our EFS file system. Click Services and type in EFS. Here we'll see our file system that is created. Let's click on it. And we'll click on Tags. And you'll see here that we have the key value pair of backup and silver. We'll use that as part of our backup plan. Let's go ahead and confirm our EBS volumes. Type this and type in EC2 and click EC2. Now, Next, let's click Volumes. You should see 6 volumes displayed. You should see a web server root and web server data volume, an admin console root, a SQL Server root and SQL Server data volume, as well as a SQL Server restore root. Let's click on Instances to verify our instances. We should have 4 instances running. We've got our backup admin, which will perform some backup administrative functions. We've got our web server. We've got SQL Server 2019 main, which hosts our Microsoft SQL database. And we've got our SQL Server 2019 restore instance, which just has the operating system and SQL Server installed, but no database. Let's verify that the web server is up and running. Click the button next to web server and click networking. We'll want to copy the public IP4 DNS to our clipboard by clicking this button here and opening up a new tab and pasting that. We'll see the EBS volume data hosted here. And if we click back, we should see our EFS hosted data here. So we verified that our EC2 web instance is up and running and is serving data out to the public. We'll also want to note the availability zone where this EC2 instance is deployed. Next, let's confirm our AWS Backup configuration. Click Services and type in AWS Backup and click AWS Backup. Let's check out our vaults. We should have 2 vaults that were created plus the default vault that is automatically created. Click on the Backup Workshop Silver Vault. You should see a couple recovery points already there. Let's take a look at the backup plans. On the left-hand pane here, click Backup Plans. You should see our Backup Workshop Silver plan. Let's click on it to see what's inside. Let's click on our backup rule number 1. You'll see that the frequency of the backups, according to this rule, happen every 12 hours, starts within 1 hour. We want it to complete within 2 hours. For EFS data, it will transition to cold storage after 1 month and expire after 4 months. And the vault destination will be the Backup Workshop Silver Vault. Let's hit the back button and take a look at the resource assignment. We click on Backup Workshop Silver Resources. We can see that resources are assigned to this backup plan via a tag policy with a key value pair of backup and silver. What this means is that any supported service that has the tags backup silver will automatically be included as part of this backup plan. So in summary, we verified that our resources deployed properly. We took a look at our web server and tested it to make sure that it was serving data out of both our EBS volume as well as our EFS resource, as well as confirming our backup vaults and taking a look at the backup plan. We also confirmed our SNS notifications to ensure that we get our emails. Let's go on to the next module. In this module, we're going to create a backup plan for our more critical volumes. We'll be using our Backup Workshop Gold Vault. The Gold Vault has an extra layer of security. It has an access policy associated with the Backup Vault. We'll get into more detail of that in a later module. For now, what we're going to do is we're going to protect both EBS root volumes for both the web server and admin server into our Gold Vault. Let's go ahead and create a new gold plan. In the left-hand pane, click Backup Plans and click Create Backup Plan. Here we're going to build a new plan. Let's type in Backup Workshop Gold Plan as our name. The rule name we'll call Backup Workshop Gold Rule 1. We're going to have a frequency of a custom cron expression. And we'll want to do this for every 6 hours. So what we want to do is type in 0/6. We're going to leave the backup window default. We'll set the expiration policy to expire 4 months after creation. And we'll select the gold vault. Let's hit Create Plan. Next, we need to assign resources. You can either click the Assign Resources button here or here to assign the resources. We'll call this Backup Workshop Gold Resources. And we're going to assign it by tag with a key value pair of backup and gold. And again, any resource that we tag with key of backup and value of gold will automatically be assigned to this gold plan. Click Assign Resources. So now let's go and tag the root volumes for the gold plan. Let's click on Services, EC2, go to Volumes. Let's find our admin console root. Click on Tags, Add and Edit Tags, Create Tag, Backup, Gold, Save. Let's do the same thing with the web server root as well. Click the web server root, click Tags, Add, Edit Tags, Create Tag, Backup, Gold, and Save. It was just that easy. The next time that backup plan runs, it will automatically include those 2 EBS volumes as part of its backup plan. So in summary, what we've done is we've created a backup plan to automatically include resources with a key value pair of backup and gold to the resource plan. We've also placed those backups into a gold vault, where we have an extra layer of security. We'll go over that access policy in our next module. In Module 3, we're going to secure recovery points in our vault. We'll dive a little bit deeper into that access policy that we have on our gold vault and show you how AWS Backup protects your backups. Let's go ahead and click Snapshots on our EC2 console. Here you should see a couple snapshots that were taken by AWS Backup. You can tell they were taken by AWS Backup because the description says that the snapshot was created by the AWS Backup service for the individual volume, as well as a description of created by create image. That tells us that the AWS Backup took an EC2 instance backup, which captured both volumes that were associated with that EC2 instance. Let's go ahead and try and delete one of these snapshots. Click on the button here, right click and hit delete. Yes. Error. We could not delete this. I'm logged in as an admin user, which should have full privileges to do any action in AWS. However, because AWS Backup is protecting this resource, the only way I can delete this is if I go into the AWS Backup console. Let's go ahead and hit cancel here. So let's take a look at our vault policy. Let's click on Services, type in AWS Backup, and go to our backup vaults. Let's take a look at our Gold Vault. And let's scroll down to the vault policy. If we look at the access policy, we have a deny that will deny deleting recovery points, deleting backup vaults, as well as denying update recovery point lifecycle for any resource where the condition is not like the backup workshop backup admin role. So what this policy will do is, unless you are this backup admin role, you will be denied the ability to delete recovery points. Let's go ahead and highlight this policy, and let's attach it to our Silver Vault. Click on Backup Vaults on the left, and click on our Silver Vault. Scroll down to Access Policy, and paste that policy in and click Attach Policy. Next, what we'll want to do is go into the backup vault, and let's try and delete one of these recovery points. Click the recovery point and hit delete. Access denied. Again, I'm logged in as an admin user. I should have full privileges to do any action within AWS. However, because I am not specifically logged in as the backup admin role, I cannot delete this recovery point. So let's take a look at how we would delete this recovery point. Let's go ahead and click. We'll want to make note of this ARN. So let's copy this to our clipboard and then to our notepad. Next, we'll go to our EC2 instance, click on Services, EC2, click Instances, and we're going to log into our backup admin. Right-click, click Connect, and we will connect via the SSH client. Click the button to copy the SSH connection string to our clipboard and connect to our EC2 instance here. Enter in Yes to save the fingerprint. And now we are logged into our EC2 instance. Next, we'll want to copy this command from our page here. Make note that this dash sometimes does not copy. So what we will do enter in US West 1 as the region. We will paste in the ARN that we copied. And you'll notice it did not copy the dash next to the backup silver. We'll add that dash in to make sure that the command works. And sure enough, because this EC2 instance has this backup workshop admin assigned to it, it is able to perform that function. If we go back to AWS Backup, click on Vaults, we will now see 2 recovery points. So let's go over the summary. So as part of this module, we learned that with an access policy, we can really restrict who has the ability to perform actions on our backups. We can restrict deletion of our resources to very specific roles. We also added an access policy to our Silver Vault and protected those backups as well. There may be times where you need to create an on-demand backup of an existing resource that is outside your backup plan schedule. In this module, we're going to create an on-demand backup of the existing EFS file system as well as our EBS data volume. Let's start by clicking on Create On-Demand Backup. From the resource type, select EBS. And from the volume ID, select our web server data volume. We're going to expire it 3 days in 3 days, and we will store this in our Silver Vault. And we're going to hit Create On-Demand Backup. Next, we'll click Dashboard again, and we'll create our on-demand backup for our EFS file system. Select EFS from our resource types, and for our file system ID, select our file system we created. Again, we will expire after 3 days, and select the Silver Vault. Click Create On-Demand Backup. You should now see both of our instances starting our on-demand backup. In this module, we were able to successfully create an on-demand backup of our existing resources for an EBS volume and for an EFS file system. And if you subscribe to the SNS topic, once these are completed, you should receive an email with the completion status. Let's move on to the next module where we'll recover some deleted data. Let's go over to our EC2 console by clicking on Services, EC2, and then Volumes. We're going to go ahead and remove our web server data volume. First, start by right-clicking on the data volume and click Detach Volume, and click Yes to detach. Click Refresh, and you should see that the blue state available is now on that volume. Right-click again, this time hit Delete Volume, and say Yes. Now let's go ahead and delete our data from our EFS file system. We're going to go ahead and go into our instances, go into our web server instance, right-click, connect, click on SSH client, and copy the SSH connection string. We're going to go ahead and connect. Yes to save our fingerprint. And we'll issue the following command. This should remove our data off of our EFS server. Let's go ahead and confirm what our web server looks like. You should have that tab open. Let's refresh. We should see that our EFS file system is completely empty. And we no longer have our EBS volume because we detached it. So now let's restore our EFS file system from our recovery point. Let's go back to our console, click Services, go to AWS Backup. Next, click Restore Backup. We should see our file system here. So we'll click our EFS file system. We'll choose the latest recovery point here and click Restore. Here we have a couple different options that we can select. We'll go ahead and use our full restore, and we'll want to restore to the directory in the source file system rather than creating a new file system altogether. And we'll leave the default role. Click Restore Backup. This should begin the restore of our EFS file system. Next, let's restore our EBS volume. Click our dashboard. Click Restore Backup. This time select our volume. Let's choose the latest snapshot and click Restore. Let's resize this to our 1 gigabyte. And recall that we were in US West 1A as our availability zone. Click Restore Backup. We now have 2 pending backups. The benefit of restoring from an EBS volume is that as soon as the backup is running, almost immediately, that snapshot will be available to use within the EC2 console. Let's click on Services, type in EC2, and let's take a look at our volumes. You should see a volume without a label right here. This is our restored volume. Let's click on this volume, right-click, and click Attach Volume. We'll want to select our web server instance, and we just want to make note of the device ID, SDF, and click Attach. Next, we should be connected to our web server here, and we will mount the EBS volume. There you go. Now, let's confirm. There we go. We are now back in action. Great. So in summary, in this module, we went ahead and restored our EBS volumes as well as EFS data using the restore function from AWS Backup. In the real world, much of this can be automated with scripting and API calls when the requirement is to work at a much, much larger scale. Let's move on to Module 6. Here we're going to do a backup and recovery using VSS integrated snapshots. In this module, we're going to create an on-demand backup of our running SQL server and then restore the data volume to our SQL Restore instance and be able to attach the database without any errors. So let's get started. Let's go ahead and create an on-demand backup of our SQL server. Let's go back to our AWS console, click Services, AWS Backup, and let's create an on-demand backup. From our resource type, select EC2, and from our instances, let's select our SQL Server 2019 main, which is running our database. For the expiration policy, put 3 days. The backup vault, let's place it in silver. And now, ensure that we have this Windows VSS option enabled. This will integrate the application-aware VSS integration with our backup and create on-demand backup. This will start our job. Once we refresh and we have it in a running state, let's go back to our EC2 console. click EC2. Let's click on Instances, and let's take a look at our SQL Restore instance. Click on Networking, and what we'll want to do is identify which availability zone this instance is in. We'll need that when we restore our volume. Next, click on Snapshots. And what we need to do is select our 10 gig volume that has our databases on it. Click on the button there, right click, and then say Create Volume. Here, we need to verify that US West 1A is the correct availability zone, and we now hit Create Volume. Make note of this volume ID, 6AE. Okay, once we've done that, we can close that. Once we've done that, we can go back into Volumes, and now select the volume that we just restored, the 6AE, right-click, and Attach Volume. We're going to select the SQL Server Restore as our instance, and we're going to attach. You may need to click Refresh to make sure that it comes back. Next, let's connect to our EC2 instance, our restore instance. Click Instances, right-click on the SQL Server Restore, and hit Connect. We're going to be using the RDP client, and in order to get the password, we need to pass it the SSH key that we registered earlier. Click Get Password, browse to your SSH key, select your key, click Open, and hit Decrypt Password. This will then allow you to copy the password to the clipboard. Once that's copied, click Download Remote Desktop File. For the purposes of this demo, I'm going to tweak the display here so it doesn't show in full screen. To get logged in, click Continue to accept the root certificate and paste your password in. Okay, once we get logged in, this instance may take a little while as it goes through its startup procedure. But once we're logged in, we can click on the Start button at Windows Administrative Tools and click on Computer Management. We need to go into the Disk Management and identify to make sure that our 10 gig disk volume has been attached. It's offline, so we need to make sure that it's online. Click Online. Next, let's launch Microsoft SQL Server Management Studio. Click Start and type in SSMS. And then launch the Microsoft SQL Management Studio 18. While we're waiting for the Management Studio to load, let's take a look at our disk drives. You'll notice that we have both our root volume at 50 gigs and now our newly attached 10 gig volume. Let's go in and double click. Disk D, SQL, and there is our AdventureWorks databases. Let's go ahead and click Connect. And this brings us to our database management. If we expand databases, we'll note that there are no databases running on the system. Let's go ahead and attach our database. Right-click on Database, click Attach, click Add, and then let's browse to the D drive, SQL, and click on AdventureWorks DB and OK. Next, click OK. And there we go. We have successfully attached our database without any errors. So in summary, with this module, what we've done, we've created an on-demand backup of a running SQL server and enabled the Windows VSS feature to enable us to create an application-consistent snapshot of that database. We've then taken and restored one of the volumes that had the databases on it on another running SQL instance. We were able to attach that database without any errors and get our data back. Next, let's go through the cleanup procedure to ensure that we clean up all of the resources that we've created properly as part of this module. It's okay to go ahead and close out this RDP session now. We're going to go ahead and delete all the existing recovery points that we have. Under Services, click EC2. Click Instances, and we're going to go into our Backup Admin. Right-click, hit Connect, and go to the SSH Client tab, and then copy our connection string. And we'll type in the following command. What this command does is it goes through and cleans up all of the recovery points within the vaults, as well as removing the access policies on the vaults and then removing the vaults themselves. If for whatever reason you had running backups at the time that the script was run, the script will throw an error. So what you could do is either stop the backups and then rerun the script, or stop the backups and manually remove those recovery points and removing the vaults. Next, we'll go ahead and delete this CloudFormation template. Click on Services, CloudFormation, click the Backup Workshop, and then Delete. And delete Stack. We usually give this a minute or two to process so that it kills all of our running EC2 instances before proceeding. Okay, let's click on Services, EC2, and then click on Volumes. And we should see our 2 volumes created and in a blue available state. We'll go ahead and select both of those, right-click, and delete volumes. Let's go to our AWS Backup to remove our gold backup plan. Click on Backup Plans, click our Backup Workshop Gold plan. We'll remove our resource assignment first by clicking on the radio button there, click Delete. We'll want to highlight our backup resource and paste the name in. And then, once we've successfully done that, we can go ahead and click the upper right hand delete to remove the gold plan. And now we've successfully completed our backup workshop. Let's head over to our PowerPoint to continue our presentation. Thank you for walking through the hands-on workshop. So let's recap what we've learned today. We learned a little bit about how AWS Backup works. We then dove deep into a hands-on workshop where we learned how to create a backup policy, how to create on-demand backups of resources. We learned about how to tag our resources so that they could automatically get enrolled into our backup plans. We also talked about securing our backups using vault access policies to really lock down who could have access to delete or take action on our backups. We also learned how to create on-demand backups using our Windows VSS feature, and we also learned how to restore various components of data through an EBS restore, an EFS restore, and also an application-consistent restore. So thank you again for taking the time to walk through this with me. Also, for additional information, you can take a look at our feature announcement page on the What's New link there. Also, our product documentation can be found at the link provided, as well as some additional resources down below. I also wanted to remind everyone that reInvent is just around the corner. This year, it's going to be a free event and covers 3 weeks worth of virtual conferences. So please register now. The conference will run from November 30th through December 18th. Again, thank you very much, and now we'll take some questions.